Yeah, I welcome you all for another beautiful presentation on signals and systems. Today, we are going to see the lecture number 8. It is lecture number 8, in which we are going to see the another classification of signal, that is deterministic signal and then non-deterministic signal. This is the another classification of deterministic signal and then non-deterministic signal. What is deterministic? What is non-deterministic signal? This is the another classification of signal. If you recall our previous presentations, we have covered the periodic signal and the non-periodic signal, and similarly we have seen what is a even signal and then what is an odd signal, and similarly in recent presentation also we have seen what is a energy signal and what is a power signal. Three classifications we have seen very clearly in detail with little bit examples also. In this presentation, I would like to explain about the deterministic signal and the non-deterministic signal. I think it is a like a theoretical part only. You will not expect any questions on this. Basically, this is only type of signal which we should know about it. That's it. You can't expect any questions on this. So in examination point of view, especially in technical competitive examination point of view, it is not that much important basically. But we should know that what is a deterministic signal and what is a non-deterministic signal. So I will explain you about what is a deterministic signal first. Deterministic means it is a determined. It is a determined means it can be completely expressed by mathematical expression. So otherwise in definition form I will explain you that any signal, okay, you can write otherwise any signal, if if it is completely specified by mathematical expression, then that signal is called a deterministic signal. Okay, if any signal it can be expressed by mathematical expression, that is called a deterministic signal. Clear? That is the definition of a deterministic signal. Or otherwise the signals which are in the random nature, they are comes under they are called as non-deterministic signal. Deterministic means that we must able to evaluate it, we must able to study it, we must able to get some particular value of it. Is it not? So whereas a non-deterministic, it is nothing but a noise signal basically. If you consider any electronic circuit, normally you will get some kind of noise at the output stage of any electronic circuit. Let us say, for example, if you consider any amplifier circuit or any circuit you take, oscillators and radio receivers, for example, if you consider all these electronic circuit, normally you will get some kind of disturbances if you measure the output of those amplifiers or oscillators or receivers like that. So that noise comes under this classification, that noise comes under this non-deterministic signal. Whereas deterministic signal, what is the example? Say for example, whatever the examples we have studied so far with respect to these classifications of signals, say for example x of t, a cos omega t, or otherwise x of t, e power at, say for example e power at. These are the examples for deterministic signal, because is x of t is equal to a cos omega t, it is a co-sinusoidal signal. So it is completely, this is what the expression of the mathematical, this is what, so so the deterministic signal should contains like this, means some mathematical expression. This is what the expression, mathematical expression can be easily evaluated. You can easily find out its periodicity. You can able to say is it periodic one or a periodic one. You can say is it odd signal or even signal. Even you can say what is the energy content of this x of t, and you can calculate what is the power content of this x of t. Similarly, this also, the second one also, this is exponential signal. X of t is equal to e power a t, it is a cosinusoidal signal. It is an exponential signal. Even for this also, you can calculate the value also. I mean energy and power you can calculate for this. Like that, the signal which, okay, the signal for which we can able to find out its value, then that comes under deterministic signal. Whereas for noise signal, it is very difficult actually. You can't because you can't find out any parameter of noise. In fact, that's why we can assume most of in our electronic circuits, the output, in the output, whatever the noise you will get, normally it is assumed as a white Gaussian noise. You know that I can explain you in my subsequent subject, which I am soon going to present you, that is probability theory and stochastic process also. I am going to start, and there we can see one of the important topic is there, chapter is there in the PTSP subject, probability theory and stochastic process, in which we will study in detail about the additive white Gaussian noise. Even in the communication also you will get that additive white Gaussian noise, that is called AW, additive white Gaussian noise, AWGN. Normally that noise, whatever the noise comes at the output of the electronic circuit, is assumed as AWGN, additive white Gaussian noise. So that particular noise we have assumed as this, and we have defined one particular property of this. Okay, so all those noises, whatever the noise we get, and most of the time we will consider it as a additive white Gaussian noise. Okay, that we will see in the latter part, no problem. So here, as far as our presentation is concerned, so under deterministic, these are the examples actually, basically. So you can give more number of examples if need, because so this is what deterministic means: any signal that should be completely characterized or completely specified by mathematical expression is called a deterministic, whereas the signal which are in the random nature comes under non-deterministic signal. This is the simple explanation about this deterministic signal and then non-deterministic signal. Clear? So with this we will complete the classifications of the signal. I think this is the fourth classifications as the order which we have started from the earlier presentation of our signals and systems is concerned, right? So in the sequence, if you remember, the first one we have seen the periodic signal, a periodic. Second one is the even signal and the odd signal, and the third one we have seen the energy signal and then the power signal, and the fourth classification, this is what the deterministic and then non-deterministic signal. Right. So in previous presentations, I have already explained you that, I told you that, so other than these basic classifications of the signals, there are some more elementary signals also there. There are some more elementary signals also called as standard signals. There are some more standard. There are some more standard signals, or otherwise they are called elementary signals. Elementary signals are there. So normally these signals can also be considered. Okay, sometimes these standard signals can also be given as an input to a particular system, because we are studying now as with respect to signals. Afterwards we will see about the systems also. What is a system? What are the various classifications of the system? So for that system we need to apply these signals as input. That's why, right? The first classification is, it is a unit step signal. The first standard or elementary signal is unit step signal, and the second one is unit ramp signal. It is unit ramp signal, and the third one is unit parabolic signal. Okay, unit parabolic signal. Unit parabolic signal. And the next one is exponential signal. What? Exponential signal. Exponential signal. And next is the impulse signal. Unit impulse, or you can call as impulse simply. Unit impulse. Impulse, very important. Very important signal it is. Unit impulse, or otherwise simply impulse, you can say. Signum function. What is signum? SIGNUM. Signum signal or signum function, you can say. These are the basic elementary standard signals we have actually. Other than this, there are 2 or 3 more are there which are not that much of important. Here the most of important is unit step. Most of the time we will consider the unit step signal, and very rarely we use ramp signals also, and most of the time the impulse signal. This is very important. Unit impulse signal is very important. Unit step is widely used. These two are very important actually. Unit step as well as unit impulse. And very rarely we use unit ramp and then exponential signal. And rarest of the rarest we use signum function. That's it, right? So I think I will finish off this particular presentation here. In our subsequent presentation, we can see in detail, elaborately, what are these signals, how these signals will be defined mathematically, or is there any mathematical expressions for these, or how these signals can be defined, can be characterized, and how these signals can be used like that. So the information with respect to each of these signals we can say in detail in my subsequent presentations. I think you have enjoyed this session of presentation. I hope that you understood this very well, and we will see in the next presentation. Okay, see you. Have a nice day.